May 1, 1960. Sverdlovsk, Soviet Union. Alone. Faint radar signal blinked across the screens of the Soviet Air Defense Command. It showed something strange, drifting with steady, unnatural calm at an altitude their manuals claimed no aircraft could ever reach 70,000 feet. Lieutenant General of Aviation Yevgeny Savitsky, commander of the 4th Independent Air Defense Army, watched as his trusted S-75 Dina missile system, called the SA-2 guideline by NATO, moved into firing position. For 4 long years, American U-2 spy planes had crossed into Soviet airspace with insulting ease, capturing images of the motherland's most secret military sites from the edge of space. The Kremlin, furious at this violation, had delivered a clear standing order: bring one down, whatever the cost. On that May Day morning, a burst of 14 missiles finally tore upward. One struck its target, shredding Francis Gary P's fragile U-2 and sending him falling toward the frozen Siberian ground. The event triggered an international crisis and gave Moscow a sudden moment of victory. They had shown that no American aircraft could enter Soviet skies and escape alive. They had slammed their airspace shut. What they did not realize, what they could never imagine, was that in a hidden facility in Burbank, California, a withdrawn genius named Kelly Johnson and his Skunk Works team were already creating the key to open that door again. It was a machine built from materials that seemed impossible, driven by engines that bent the rules of physics, and shaped to fly so high and so fast that for the next 25 years it would treat the mighty Soviet air defense system not as an obstacle, but as a landmark to photograph on the way to its next objective. Soviet pilots would eventually know it as the Kurnaya Titsa, the Blackbird. For years, its abilities were so unreal, so far beyond anything they had, that many believed it was a myth, a piece of American fantasy, until the day it tore over their heads at 3 times the speed of sound and disappeared before they could even line up a missile shot. The downing of Gary P's U-2 was more than a political setback for President Eisenhower. It was a strategic disaster. The United States had depended on the U-2's intelligence to judge Soviet missile strength, easing public fears of a supposed missile gap and guiding calm, careful planning. That intelligence was crucial, but the method was now exposed. A new reconnaissance aircraft was needed, one not just hard to hit, but literally impossible to catch. That responsibility went to the one man in America known for making the impossible real, Clarence Kelly Johnson, the famous leader of Lockheed's Advanced Development Projects, a group so secretive and unusual that it was simply called the Skunk Works. The demands placed on Johnson seemed to break every known rule of aircraft design. He was asked to build a plane that could cruise faster than Mach 3 at altitudes above 80,000 feet. It needed a range of more than 3,000 miles while carrying a heavy set of cameras and sensors weighing over a ton. At such extreme speed, the air rubbing against the skin would heat the aircraft to nearly 1,000 degrees Fahrenheit, hot enough to melt normal aluminum like butter and slowly bake the pilots alive. The program, codenamed Archangel, would require a machine created for conditions closer to outer space than to the planet below. The first problem was the aircraft's material itself. The only realistic choice was titanium, a metal as light as aluminum but strong like steel, able to survive the burning heat of sustained, high-speed flight. The issue was that in the early 1960s, the world's main supplier of high-quality titanium was the Soviet Union itself. In one of the Cold War's greatest ironies, the Central Intelligence Agency, the very future user of this new aircraft, was forced to create a complex network of shell companies and hidden agents across the globe. Their mission was to quietly buy the same Soviet titanium needed to build the spy plane that would spend its life spying on the Soviet Union, Moscow. hungry for foreign currency, unknowingly sold the raw metal for its future rival to American front companies, who then secretly shipped it back to the Skunk Works facility in California. Even once the metal was secured, shaping it became a manufacturing nightmare. Titanium was extremely brittle, snapping normal high-speed steel drill bits within seconds, and welding itself to cutting tools if not handled with great precision. Johnson's engineers had to invent brand new production methods from the ground up. They built custom carbide tools, created new lubricants, many of them basically distilled water. Since normal fluids ruined the metal and trained a whole new generation of machinists in the careful craft of working with this strange material. The next impossibility was the engine. No regular turbojet could function in the thin, oxygen-poor air at 85,000 feet or survive the enormous heat produced at Mach 3. Pratt and Whitney was given the challenge of building a power plant that could act like a standard turbojet at low speeds and switch into something close to a ramjet at extreme altitude. The result was the J-58, an engineering wonder that behaved more like a controlled continuous explosion than a traditional engine. Above Mach 2, large movable cones at the front of the engine nacelle slid backward, forming a perfectly shaped shock wave that compressed incoming air without relying on normal compressor blades. The engine essentially fed itself, becoming more efficient the faster the aircraft flew. Its fuel, a special low-volatility mixture called JP7, was so stable that it could put out a burning match. It had to be lit using a shot of triethylborane, or TEB, a chemical so reactive that it bursts into bright green fire when it touches air. The final aircraft, labeled the A-12 for the CIA and later refined into the SR-71 for the Air Force, looked as if it had come from another planet. Its fuselage used a set of blended curves and razor-sharp edges, called chines, that stretched along the sides of the forward body. This shape was not only for aerodynamics, it was an early and very effective form of stealth. Though not a true stealth aircraft like the later F-117, the SR-71's design, combined with radar-absorbent iron ferrite paint, scattered and weakened enemy radar waves. On a Soviet screen, the radar return of an 18-ton, 107-foot-long aircraft appeared only for moments, no larger than a small bird if it appeared at all. The Blackbird was created to be a ghost long before it ever took to the air. On the ground, the aircraft was a strange and leaky machine. Its fuel tanks were built into the skin itself and designed to expand under the burning heat of high-speed flight. This meant that when cold on the runway, JP-7 fuel constantly seeped through the sealed joints, forming small puddles beneath the aircraft. It became fully sealed only in its true home 85,000 feet up. Racing through the upper atmosphere at 2,200 miles per hour, while the Skunk Works was building its legend, the Soviet Union was creating a monster to destroy it. Hurt by the U-2 incident and alarmed by intelligence suggesting America was developing the B-70 Valkyrie, a Mach 3 nuclear bomber, Soviet Premier Nikita Khrushchev demanded an An-Sen-Tuan-Chindanan interceptor that could counter this high-altitude, high-speed danger. The Mikhail-Gurevich Design Bureau was ordered to create a fighter that could reach 75,000 feet and Mach 2.8 while carrying powerful long-range missiles able to destroy a bomber in one strike. The answer was the MiG-25, known to NATO as the Foxbat. The MiG-25 was a triumph of raw Soviet engineering. Unable to master the use of titanium, its designers relied on huge amounts of nickel-steel alloy, essentially welding together a fighter that was extremely heavy but incredibly strong and resistant to heat. It was driven by two gigantic Tumansky R-15 turbojets engines, so intense they glowed red at full power and could throw the 36-ton aircraft toward the edge of space in a near-vertical climb. Its Smercha radar was among the most powerful ever placed on a plane, so strong that ground crews were warned not to stand in front of it while active for fear of being cooked. It carried 4 huge R-40 air-to-air missiles, each the size of a small telephone pole, built to destroy a high-altitude bomber with one hit. When Western intelligence first spotted the MiG-25 in 1967, its apparent abilities caused serious alarm in the Pentagon. It was believed to be a highly agile superfighter, a belief only corrected in 1976 when pilot Viktor Belenko defected to Japan with his Foxbat, exposing it as a fast, straight-line interceptor. The stage was now prepared for a meeting between 2 of the most remarkable aircraft ever created. On one side stood the SR-71 Blackbird, a sleek titanium-skinned thoroughbred built for speed, height, and slipping past danger. On the other stood the MiG-25 Foxbat, a steel-armored giant designed with a single mission to climb toward the stratosphere and destroy anything it found there. The SR-71 began operational flights in 1966 from its bases in Kadena, Japan, and RAF Mildenhull in the United Kingdom. It carried out missions over Vietnam, North Korea, the Middle East, and above all, the Soviet Union. The typical mission over Soviet territory was a carefully timed performance that pushed the limits of physics. Life for a Blackbird pilot was unlike that of any other aircrew. They belonged to a tiny elite group who underwent astronaut-level medical tests. Before each flight, they ate a special high-protein, low-residue meal like steak and eggs, then spent an hour breathing pure oxygen to flush nitrogen from their blood and avoid decompression sickness. Dressed in a full pressure suit, they walked to the waiting aircraft, which sat on the runway dripping its JP-7 fuel like it was already alive. After takeoff, the Blackbird would meet a specialized KC-135Q tanker for a full load of fuel. Then the pilot advanced the throttles. As the SR-71 pushed through the sound barrier, a second tanker topped it off one last time. From there, it was a fast, thrilling climb toward the upper atmosphere. At 80,000 feet, the pilot eased the jet beyond Mach 3. Outside, the sky darkened into a deep indigo. The curve of the Earth became clearly visible. Inside the cockpit, the pilot and the reconnaissance systems officer, or RSO, were essentially astronauts. Their world was a calm blend of automated instruments, the steady roar of the engines, and the RSO's voice tracking the cameras and electronic sensors. It was during these flights, nicknamed the Baltic Express or Barents Sea Run, that the legend of the Blackbird took root in the minds of Soviet pilots. As an SR-71 neared Soviet borders from the North Sea or the Pacific, the full force of the PVO Strany sprang to life. Early warning radars spotted the intruder, and the alert would spread across the Soviet Union's Northern Command. From air bases across the Kola Peninsula and the Baltic states, squadrons of MiG-25s would scramble. A Soviet pilot sitting on cockpit alert would hear the siren and sprint toward his Foxbat. He climbed into a machine built for pure speed, not comfort or smooth handling. With the deafening roar of its huge engines, he would launch into a full-power climb, pushing both the jet and his own body to their absolute edge. His ground-controlled intercept officer guided him, calculating a path to a point in the sky where he might get a chance to fire. His aim was to reach 60,000 to 70,000 feet and pull off a snap-up missile shot, launching his R-40s in a steep arc toward the target far above him. In the back seat of the SR-71, the RSO would see his display flare with warning lights like a Christmas tree. Each light showed a Soviet radar locking onto them SA-2 sights, SA-5 sights, and the powerful Smercha radars from the rising MiG-25s. The RSO managed the defensive electronic countermeasures, but the Blackbird's real defense was its raw, unreachable speed. Soviet Mach pilots saw the SR-71 on their radar as a tiny, fast-moving blip traveling at speeds their manuals claimed were impossible. They shoved their engines to their limits, the steel frame of their jets groaning as they climbed, trying desperately to reach firing distance. But the intercept geometry was always against them. The Blackbird cruised at Mach 3.2 over 2,200 miles per hour. The MiG-25, even at its fastest surge, was still slower. By the time a Foxbat reached its top altitude, its engines overheating and its fuel dangerously low, the SR-71 was already many miles ahead. The missile launch window was unbelievably small, if it existed at all. Former SR-71 pilot Major Brian Schul once described a mission with his RSO, Walter Watson, where they were flying over Libya. After finishing their photo run, they turned toward the Mediterranean and spotted a French Mirage coming to greet them. Out of courtesy, they slowed down. At that moment, a Libyan surface-to-air missile site locked onto them. The only way out was speed. Schul shoved the throttles forward, and the Blackbird kept accelerating faster than any SR-71 had officially flown before. The missile fell far behind. The aircraft always had more to give. The Soviets tried everything. They placed MiG-25s along predicted routes, hoping for a head-on meet. They attempted coordinated launches from several airfields to trap the intruder. They fired wave after wave of surface-to-air missiles. Nothing worked. The SR-71 was simply too high and too fast. For Soviet pilots, it became a painful and humiliating routine. They would scramble, burn nearly all their fuel in a brutal climb, only to watch the target streak across their radar and vanish into the distance. After a few hopeless minutes, they had no choice but to turn back beaten without even firing a missile. The Blackbird became a ghost that ruled their skies. The psychological effect on the Soviet military was enormous. They had spent an enormous sum building what they believed was an unbeatable air defense network. The PVO Strany was a point of national pride, the shield of the motherland. Yet one American aircraft could fly along their borders without fear, dipping into their airspace whenever needed, taking pictures of their hidden naval bases at Murmansk and their ICBM fields at Plesetsk. In 1976, the West got its first clear look at this frustration when Soviet pilot Viktor Belenko flew his MiG-25 to Hakodate, Japan, and defected. During his long debriefing, he spoke in detail about the SR-71. He confirmed that Soviet pilots viewed the Blackbird with a mix of fear and admiration. He told CIA interrogators that official policy was to try for a head-on intercept, but no pilot had ever managed to get into a firing position. He explained that every successful SR-71 mission over the Soviet Union was seen as a major failure for PVO commanders, often leading to demotions and ruined careers. The aircraft was as much a political weapon as an intelligence tool, a constant, unreachable symbol of American technological dominance for the pilots on the ground, who heard only stories of failed intercepts and saw impossible radar traces. The Cha wasn't just an airplane at all. It felt like a mythical creature from another sky. The information collected by the Blackbird was priceless. Its high-resolution cameras could capture a license plate from more than 16 miles away. Its electronic sensors could map the entire Soviet air defense radar system, storing their frequencies and patterns, knowledge crucial for planning possible B-52 bomber routes in case of nuclear war. It observed Soviet naval operations, watched the building of new Typhoon-class submarines, and provided solid confirmation for the SALT arms control agreements. The SR-71 delivered what intelligence experts call ground truth, preventing the kind of fear and misunderstanding that could have pushed both superpowers into a nuclear conflict. Across its 25-year career, An estimated 4,000 missiles were launched at the SR-71 by different nations. Not a single one ever hit. Its combat record is unmatched, 0 losses to enemy fire. Its only true enemies were physics and the overwhelming stress of its missions. 12 of the 32 aircraft built were destroyed in accidents, proof of how dangerous it was to fly at the very edge of what was possible. The last chapter of the SR-71 story arrived as the Cold War faded in 1990, citing its extremely high costs over $200,000 per hour and the growing capabilities of spy satellites. The Air Force retired the Blackbird. It was briefly brought back in the mid-1990s after Congress argued satellites were too predictable, but the aircraft's era was ending. On its final retirement flight in 1990, an SR-71 flew from Los Angeles to Washington, D.C. to be placed in the Smithsonian. It made the trip in just 64 minutes, setting 4 new speed records along the way. It ended its service in one last blaze of glory. The SR-71 Blackbird was a machine, built for a specific era and a specific mission. It was the ultimate symbol of Cold War technological rivalry, a sword of Damocles hanging over the Soviet Union. Not with the threat of bombs, but with the threat of total, undeniable visibility. It proved that no secret could be fully hidden, no border completely closed. For the Soviet pilots who chased it, it became a phantom, a legend of titanium and fire that laughed at their best attempts. They saw it on their scopes, racing at impossible speeds. And as they reached the top of their exhausting climb, it simply disappeared into the dark, star-filled sky, leaving them alone with the harsh limits of their machines. The Blackbird's greatest legacy is not the secrets it gathered, but the war it helped prevent. By providing a clear, honest picture of the other side, it dissolved the myths and fears that might have triggered a nuclear exchange. It was a weapon of peace, created for a war that, thanks in part to its silent watch, never happened.